Now I'm starting, right? So this first screen is appearing in that, and I think you have understood already. So this is just KCL here, right? And this is again KCL, and in this we have already taken one extra branch about which we have no information, that there is maybe capacitance or something else. We don't know about it, but it is there. So if I write equation for such case, then it will be the equation Q is equal to. I could do this thing also here. Let me tell you one more thing. I have no information of this about this branch. There could be some other thing also here. I could say, I could make a loop. Maybe there's a capacitance here also. That is possible. Or maybe there's not a capacitance, but this is connected to some other node. Or if it has capacitance, then why would I write Q here? Why would I not include that one also? I can give you reasons. Sometimes they ask, examiner asks sometimes in such a way that what charge flows through this branch. He may ask what charge flows through this branch. So if I have to ask what charge flows through this branch, then in order to determine that Q, what could I do? I could use such equations maybe in order to get the value of Q. That is possible sometimes, right? So there may be necessity sometimes, and sometimes there may be no option. Means after this, it may be again going to some other nodes
That will be
where there
splitting.
may be,
So
it may be splitting into some other complicated circuit. It may be splitting into some other complicated circuit. So we have no option. Okay, then we will have to take like this only. We have to write this as Q. Fine. So this is what we do in such cases. Next we have using this knowledge which you have gained till now, you can do almost any question using anti-symmetry also. I'm not telling anti-symmetry again. I'm not telling the symmetry, because those methods, those concepts are exactly same. One example I can take from anyone having SCV right now. We can take one example from SCV. If somebody is having SCV, there is one very nice example of SCV of anti-symmetry in.
Yes, sir.
Please, no, it is open it once in this chapter and see what is that question. I'm just drawing it diagram. You will understand. It is an exercise. It is an exercise. You just tell me the values of the resistances.
Take C1 equal to 4.
This way. This way. This way it is. Now you tell me, what should I take here in this place? It is an exercise of capacitance chapter.
Or like that many questions are there, sir?
No, there is just one question only in which there is such network. 1, 2, 3, 4, 5, 6, 7, 8. There are not many.
Top left corner 1 UF, sir.
Top left.
Top left corner 1 UF.
Okay, 1 microfarad.
1 microfarad. Right side 3 microfarad.
Okay.
Bottom 4 microfarad.
Bottom.
Just below, sir. Just below.
Just below vertical.
Above the center, sir. On the vertical line, above the center.
4 microfarad.
Below the center 4 microfarad. Right side the center 2 microfarad. Yes, sir. 2. Exactly, sir.
Right. This we can tell because you told me that information. Now I understood, because it's anti-symmetric circuit.
So it is anti-symmetric.
So for anti-symmetric, it will be like this only. Yes. We have to find out what is the net capacitance, I think, right or not? What is net capacitance? What is the equivalent capacitance of this network between A and B? Between these two terminals, what is the equivalent capacitance? So
now we can assume charge.
This, if I take one mirror here, then we are not having mirror images. But after one mirror, I have to take second reflection again. If I have to take two reflections, then it is anti-symmetric circuit. And what happens in anti-symmetric circuit? Or normally I said
difference will be
same thing. Here potential difference and here potential difference will be same. In this potential difference and in this potential difference will be same, means the charge stored here and the charge stored here will be same, because C into V is the charge. So charge here and charge here will be same. Similarly, this place charge and that place charge will be same. And what else I told you? I told you that this midpoint in such case, this midpoint will be having potential half of. If it is 1,
sir, half of that.
If it is 0 volt here, then it will be 1 by 2. 1 by 2 volt. This midpoint will be having 1 by 2 volt. This idea we are having. So 1 by 2 we know here. This potential, let us assume it to be V.
We can
if it is V, then this one
will
is
become
1
minus V.
1 minus V. But wait, say, I don't need I don't need this lower one. If I use this information that it is half, then I don't need this lower one also. The reason is this single equation will be enough to get the answer. So just let us try to get the answer now. I have to write equation for this single node, this node only, this node here. I will take this loop here and I will take V minus V1. What is V1 here? It is 1 volt. It is
V
connected to
minus
1
1
volt.
into 1, sir. V minus 1 into
So let
1.
us write V minus 1 into 1 plus. Second node I am taking
V
vertical
minus
one.
0 into 3.
Vertical one is V minus 1 by 2
Half
into 4 plus the other horizontal one is V minus 0
into 3.
into 3 is equal to 0 total.
Yes.
So what is the value of V coming out to be? Let us check now. Add these 1 plus 4 plus 3, that is 4 plus 4, 8 minus
8 equal to 3, sir.
minus
equal to
3
3, sir.
is equal to 0. So V is coming out to be 3 by
3
8. We are getting V value. After getting V value, what is our next step? To get the capacitance, what is the equivalent capacitance meaning? Equivalent capacitance meaning I should have single capacitor, which will, when connected to 1 volt battery, it is connected to 1 volt. So when that single capacitor is connected to 1 volt, then it should draw same charge from the battery as this is drawing. Means what should be the charge entering in this side? Q, same charge as it is entering here. Okay, then I will say that this is same as this small one. Okay, single capacitor. So what I need to do now, this charge gets split into parts. It may give here Q1 and below it may be Q3 and in middle it will be Q2 maybe. So this Q, if I use KCL in this, like in this junction, whatever in this junction, nothing can be stored. So in this junction, if Q has entered, then what has gone to this side? Q1, this side Q2 and this side Q3. Or I can apply for this way also. This way I can say, initially charge in this capacitor was 0. So whatever charge is stored now, Q1, Q2, Q3, that must have come from outside through this wire only. So therefore Q is equal to Q1 plus Q2 plus Q3. Okay. So what is the value of Q1? What is the value of Q1 and Q2 and Q3? Can you tell me?
Q2 we can find as 1 minus
equals Q2 equals and Q3 equals what? It is C into V minus 1 into 1.
Yes, sir.
And no, 1 minus, sorry, not
1
V minus.
minus V, sir.
Correct. Because I have taken this side, I have taken Q1. So I have to take this side as positive. This side I have taken Q2, this side is positive. This side I have taken Q3. This side I have to take positive. Wherever we assume the charges, that side I told you, rule is that side we should take positive, other side we should take as negative. So yes, we should take 1 minus V into C. Right? Very good. 1 minus C V into 1. Next is
that is 5 by 8, sir. 1 minus
1
half into
minus 1 by 2 into 2. Next 1
minus V.
Minus
no, sir. V, 1 minus 1 minus V.
1 minus 1 minus V whole into 3. This last one we can write again. It will become V minus
3V, sir. 3V.
3V, sir.
It will become 3V.
3V.
Which one?
Last one, Q3.
Q3, sir.
3V, sir.
3
It
into
will
V,
become
sir.
3V. Yes, it will become 3V.
Yes, sir.
So it is 3V only. Right.
Sir, 5 by 8, 1, 9 by 8.
So we are
Yes,
getting the
sir.
charges now finally. Charges are Q1 is
5 by 8, 1,
5 by 8,
9 by 8.
1 minus V. 1 minus V means 1 minus 3 by 8 into 1. And Q2 is equal to, that is equal to 5 by 8. 1 by 2 into 2. That is coming out to be 1 only.
Q3 is equal to
and Q3 is equal
8.
to 3V. 3V means
9 by 8.
Okay.
Done.
These are the charges. Coulomb, microcoulomb, sorry, microfarad, because it was charge will be micro then. Microcoulomb, and microcoulomb. Right. Okay. Microfarad times C into V. Voltage will become microcoulomb. So this is answer. Now you can see the answers once. What are the answers given? Right. Next we have. So see how easily we are able to do this just by one equation only, and we can always use such concepts. So similarly, if I have a question of cube, you can do that also. Have you seen the answer? Just in case there is no calculation mistake, conceptually it is okay only. I wanted to see.
7 by 4, sir.
Sir,
They asked me equivalent
Answer is
capacitance.
11 by 4 microfarads.
Answer is they're asking
different
capacitance.
answers.
They are
No,
asking capacitance.
Equivalent
Equivalent
capacitance.
capacitance.
4
So
by
that we
11
will get
Q by 1
that we have to get till now also we have not obtained. Q will be what here? Q will be equal to
11 by 8.
Q1
adding
plus
the
Q2 plus Q3.
11 by 8, sir.
11 by 8 and then equivalent
11
capacitance.
by 4.
Right, sir. Then we are also getting
11 by 4, sir. 11 by 4.
11 by 4 it is.
4.
And then equivalent capacitance will be net. See here, equivalent. What will be equivalent capacitance? C into 1 will be Q. C equivalent into 1 will be Q. C equivalent into 1 will be this charge Q, which is equal to 11 by 4. So C equivalent will be equal to 11 by 4 microfarad. Have they given that answer?
Yes, sir. Yes, sir.
So right answer.
Yes, sir.
This is it. Next we have similarly for cube also, you know. Okay, let me take one example of cube. After that, I will leave it on you. You should be able to do it yourself. One example I'm taking for the cubes. Or I could take one example which I did not take for the resistances. Yes, that means I will be able to tell you the concept of cube also, and this way I will not repeat anything which already covered. But one example, let me take that which is already covered also, and that is, you know, simple example. There are capacitances in every branch, equal capacitances, and we have to just find out what is the net capacitance. Assume all capacitances to be equal to C, and then find out the net capacitance.
Rotation, sir.
How to find out? If
By
the
rotating along
by rotating, we can tell that the potential at let us name some points A. This is A, B. We want to find across A, B. Other points I am naming C is same potential, and G, F, G, E is same potential. F, G, E, E, Z. Sorry, F, G, H, E, Z same potential. If these three are at same potential and these three are at same potential, then the charges there will be equal.
Q by 3, Q by 3, Q by 3.
Yes, Q by 3 each, Q by 3 here and Q by 3 here. And then it will become Q by 6, Q by 6. Wait a second, I forgot to draw the vertical capacitors. I have to draw first here. This one and this one. So there will be two vertical capacitors in this branch and in this branch. Now, it will be Q by 6 in that. Q by 6 here and Q by 6 here. And then again it will become finally Q by 3 when it reaches the last one. Here it is again Q by 3, here also Q by 3, and here also Q by 3. So Q by 3 I have all drawn, Q by 6 I have left few. You can understand the remaining ones are all Q by 6 only. This is Q by 6, Q by 6, Q by 6. This one is Q by 3 already written. Fine. And this one is here Q by 6. So when this Q by 6 comes here, then and moreover, which are the positive? This is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. This is minus Q by 6 here. Positive, negative, positive, negative. How positive, negative? We are going in this direction, so we understand how to take positive, negative, right? Now we don't need all this stuff. We have to just take any one branch here, and here I have taken the battery to be of 1 volt battery, and then again return back from there, return from here, and like this here. This is the loop form. So what do we get then? We are getting it as start applying KVL. Start from here. How to apply KVL? KVL we will apply. We will take the potential increase, minus to plus. It is increasing. How much it is increasing? KVL in loop shown. First, I'm starting from, let us take some reference here. I'm starting from this reference point and I'm going this side. So it is increasing by 1 volt. So it is 1 volt. And then it will decrease in every capacitance, it will decrease. What is decreased now?
minus CQ by 3.
Minus Q by 3
Q by 3
C. then minus q by 6c, q by c,
C
minus
minus
q by
3C.
this, and then again q by 3, minus q by 3 c
C
is equal to, we are reaching back the same place. So net sum of net potential sigma vi will be 0. What we get then q value? Q value is coming out to be equal to, no, let us check it once. Q by 3 will be 2q by 3, then 5q by 6.
5, sir.
5q by 6c is equal to 1. So we are getting
equal to 1.
So we are getting q total is equal to 6c by 5. Once we know the total q, can we get the value of v from there? Yes, we can get easily. What's the value of net v? In the equivalent capacitance, this will be a single capacitor which will be drawing the same charge. The charge is known to us now. And the battery will be here. 1 volt, we can get the C equivalent here. C equivalent into 1 should be same charge, which is 6C by 5. So we are getting C equivalent as 6C by 5 only. Answer. What we got for R? For R, we were getting 5R by 6. Remember?
5R by 6, sir. Yes,
Means
sir.
what is the simple logic? How to do simply? If we want to find only R, take the coefficient of R and invert it. Take reciprocal of that. Take the coefficient of R and take the reciprocal of that. We will be getting directly C equivalent. Always it will happen. Always, not only in this case, always it will be same
For
thing.
adjacent, sir, it is 12 by 7, sir.
For the what was in that case for
Adjacent,
other sides?
sir.
I don't remember.
A-
What was
A-
in this?
AD.
What was the
7
R?
by 12, sir.
It was 7 by 12. Then it will become 12 by
7
7C.
by 12.
12 by 7C.
12 by 7C then. 12 by 7C.
Yes, sir. And another is
Always
3R
like
by
that
4,
only.
sir.
Wait a second. Let me ask you another question. For example, this is given 1 ohm, 3 ohm, 4 ohm, 2 ohm, 2 ohm, 3 ohm, 1 ohm. Let us say these are all resistors. Then what will be the equivalent resistance? As can you get the equivalent resistance from here? If all these
4
resistors
by
only.
4 by 11.
4 by
R.
Here, yes, exactly. We will be
4 by
getting equivalent
11.
resistance
4 by
4 by 11 ohm.
11, sir.
Simple. Simple always like that only. Okay. Always we can do like that only. First, if you want to find out, if you can treat all these like resistors. You can treat all these like resistors and then find out the effective resistance. And after that, you can just take the reciprocal of that and that is answer.
So C is
Always.
inversely proportional to R, no, sir.
This will be completely stupid thing to say. C is completely different, R is completely different. There is no such relation.
Only
So if
calculation wise.
it is just calculation because we know it is coming out to be in the same way. And why it happens in the same way? The reason comes out from, because there we write the equation like this. V is equal to I into R. There it gets multiplied. And here we are writing V is
Here
equal to
Q by C.
Q
sir.
by C. So that is the reason that here it is coming out to be inversely proportional. Here it is coming out to be R. But if you are saying
R
that this is
inversely
inversely proportional, that will be completely wrong thing to say. This is separate equation. This is separate equation. They don't have any relation also with each other. This is just a kind of a trick. Okay.
Okay, sir.
So right. Although in some other places, in some other situations, we can have such equation also where C will become inversely proportional to R, but that is completely unrelated with this. There is something called as time constant. Time constant formula is equal to R into C. So if somebody says there are different circuits with same time constants, then resistance will become inversely proportional to C because R will become equal to time constant divided by C. So that is different because that there the equation is different. But here we have no such direct equation between C and R. So we cannot say such things, right? Next. Next we have. In fact, I told you already this thing. I think I told you that R into C we can write as rho into epsilon. And this I can say that C will become equal to rho into epsilon by R. But here also it serves as a trick only because I told you it is applicable even for those cases where rho is not even defined. For example, if it is vacuum also, then also this method helps us. Just we replace rho by epsilon not A by D in one case, and no, not rho by epsilon. We replace rho by 1 by epsilon, and then we get the other value. Means if resistance is known, if resistance is rho L by A, then capacitance we can get by this formula R into C
A sigma naught
is
by
equal to
A.
rho into epsilon. Okay. right? Now we have there are some interesting questions in Irido based on this capacitance topic. Let me take a few of those questions. I should. Let me take Irido only.